Without any further ado, or a don't, I want to thank Elmer for agreeing to do this. And Elmer, why don't you just take it away and introduce yourself and have at it.
Thank you, Bill.
Okay.
Sure. So, as I said, my name's Elmer Veith. I currently work with a company called Reliable Design Services. We're based outside of Dallas, Texas, but I keep myself camped in Atlanta, Georgia. Reliable is we're probably we're the almost newest truss company in the industry. We have an industrial side called Metroplex Conveyor, but on the entertainment side of Reliable, in addition to entertainment, we also do things like access platforms, mezzanine systems, things. We keep our hands kind of on both sides of the world, which has been real helpful for the last year. But in general, we're a fabrication company dealing in steel and aluminum, building industry standard products as well as customs and one-offs. You'll see a number of examples of projects of ours here in the deck that's coming up. I've been working in entertainment full-time since 1996. I started out as a lighting guy. Actually have a degree in TV production and took a wrong turn. Ended up in rigging and moved down to Georgia at the beginning of 1999. I went to work for Atlanta Rigging Systems, built their sales company, left there and went to Total Structures in 2006, and then ended up joining Reliable in October of 2018. I get to see and hear Bill at least quarterly with the ESTA Rigging Working Group. I've been a member of the working group since I joined officially in 2007. I've helped with the most recent revisions on E1.2 and 1.21, which are the truss and outdoor structure standards. And I led the task groups for the updates of E1.6-2 and 1.6-3, which are the chain hoist manufacturing and chain hoist usage standards. And I'm on a few other task groups there. So that's me. And I'm the recording secretary for ESTA. That's right. I'm an officer there now too. So yeah. So as we go through, I'm about to share my screen here, but I am a Yankee at heart, so I talk fast. If I am going too fast, flag me, let me know. If I hit something that doesn't make sense, if you have questions, feel free to call out. We will stop throughout and kind of check back with everybody. And I know Bill will keep me on task. I have great faith in that. Yeah,
Elmer, if I may, guys, don't call out with your questions. There's too many of us. As always, throw them into the chat, and I'll pick them up from there, and I will lob them at Elmer as the need arises. And yeah, Elmer, when you get to a stopping point, you do want to take some questions, let me know, and we'll do that.
Cool. All right. So you all should be able to see my screen now, I hope. Yes.
Yep.
Okay. Come on, technology. There we go. So what are we talking about here? We're talking about ground supports. They take a lot of forms, but in general, it's when we need overhead support for something and we can't rig it or don't want to rig it from a building. That either means we're outdoors, as a bunch of these pictures show, or we're inside and we just don't, either the building can't handle it or we just don't want to deal with the additional challenges of rigging. They take a number of forms. As I said, you have stick built, you have self-climbing, and here we go. Stick built, self-climbing, and crank towers. I'm going to tell you now, this is the only picture of a crank tower image I have because, well, that's from my horror reel, and I was really trying to find good pictures, and I just couldn't. Stick built, it's again what we said it is. You have fixed corners, you have fixed legs built with truss or tower product depending on the size. Everything is bolted. You need equipment to put it together. Self-climbing, you get to build the grid pieces on the ground and then put them up to trim via motors. Crank towers, they're kind of the hybrid. It's not a real self-climbing tower. It doesn't usually need electricity. I think there are some electric or air towers out there, but you can build things lower to the ground and then raise it up. Everything has a pro and a con. So stick-built structures, in some ways they're simpler. There's no moving parts. So we're not worried about, chains getting twisted going over head blocks. We're not worried about making the sleeves stay in place exactly. In general, they can be lower cost because we're not dealing with the extra cost of chain hoist, control systems, power, all that. The connection is easier for engineers to look at. We're going to get into that a little bit further in, but it's pretty easy to wrap your head around. I have a corner block and I'm bolting things into it. We have a physical connection. Life is a little simpler to work things through. The drawbacks are you've got to get the thing up in the air somehow. And if it's more than 3 or 4 feet, we're talking about some kind of equipment. The picture that's on that page was a structure that I did, I think that was in 2019 for Infinity cars out at Pebble Beach. And because of the conditions of environment and everything, we just didn't want to do a self climber, so we stick built it. But then that meant bringing in a small crane for the load in and the crane for the load out. So while you may not have the investment in your inventory of chain hoist and control, you're going to have ongoing costs for the job sites of the equipment. And there's another picture in here of a trade show booth that I did for a client, and it's great. It's a stick built, it's simple, but part of the labor package is 4 Genie crank towers or whatever flavor you want to call it that we get that week to get the thing up to height. And then the other issue is it's more difficult to adjust the height on the structure. Obviously, the legs are the legs. You need more pieces or different pieces if you want to change, what your trim height is. For installation projects, not a big deal. Goes in, that's it. But for temporary systems, it becomes, certainly more complicated. Self climbers, the name's kind of is pretty self-explanatory. You build it at ground level, you put the towers through travel blocks, hopefully. Not all of them have that, and we'll talk about that a bit. And then you push the magic button and the thing lifts itself up to trim height. Great, awesome, simple. If depending on what you're doing, you also adjust the height easier. The stage in that picture, those were 45-foot towers. So we had 35 feet of trim over the stage. But it's real easy. If they were doing something that wanted 25 feet, well, then you just don't run the motors out as far. Theoretically, you don't need that extra equipment. You don't need a crane. In most cases, the towers can be built so that there's either an arm that stands them up, or you can stand them up just through sheer labor force. Not always. This stage, they do bring a small crane in to set the towers because those are 45-foot tall steel towers. So each tower is 1,500 pounds, and you get the head block on it, I guess. You do need chain hoist and control, which means you also need the power supply for it. So if you're out in a field like this, you need to get a generator brought in. So you have the extra hand holding of that kind of thing. And there's more details. We have to deal with, indoors are out, you still have chains or something going up over head blocks. So you have to access the top of your towers. So now we put ourselves in a situation where either a lift is going to be required to do that, or fall protection is going to be required. So there's just more thinking and planning. Crank towers or Genie structures. See, there's no picture. I looked for a good. I don't normally have one on my usual training decks. I couldn't find one. I called my usual crew that I teach with, Eric Rouse and Jeff Reeder and stuff, and no one had a picture of a well done crank tower system. Not saying it can't be done, and we'll talk more about that, but in general, a lot of times they get used in ways that really isn't maybe the best tool. It's just the tool they have, but there are advantages to them. They're hand powered, so you don't need a power supply for them. Because they're crank towers, because they're lifts, well, you can adjust your trim height as well. You can do more of your work down at grade, which is usually safer rather than having guys up on ladders or in lifts building the thing. So you take it up to trim once it's done. Drawback though is depending on the size of the structure, you have usually from 2 to 4 or even 6 manually operated units being run by different people trying to move this thing. So you have to make sure that somebody's actually directing, and to make sure all the guys that are operating are listening, to make sure it's being lifted up evenly, that it's not sliding off the forks, anything like that. I think Bill was it was LDI 7 or 8 years ago, maybe even more than that. But the crew was putting up someone's trade show booth. It was a 40-foot diameter circle that was going to go up on 4 legs once it was at trim. They had, I think they had 4 lifts on it. Well, they were taking it up and they weren't paying enough attention. One lift got way behind, and the next thing you know, the circle slid off the lifts, took down 2 of the genies, and crashed the circle into the floor. And everyone in the hall stopped because we all heard the crash. I was building my booth about 4 aisles away, and there was a big curtain wall in between. I kind of stuck my head around the wall to see what happened, and then I went and hid back in my booth because I didn't want to be there.
Yeah, something very similar to that happened at Plaza, I think 3 or 4 years ago, striking the show. And when they were up at Exeltech, when they were up out at up in that crazy venue out of town.
Yeah. I mean, it happens, and it happens a lot. I mean, I often am on site, helping clients put their booths in and stuff that I've designed, and I'm more stressed out picking up a trade show booth for a 20 by 20 space on 4 genies than I am moving, that stage roof you saw. I mean, I always get a little cotton mouth first time we run the motors on a new roof. I'm just a stress ball for several hours when we have genies out.
Right.
Especially when, something like that, you don't know what you're getting. The labor company shows up with them. And I had a job a year ago, last time I had shows. We were at NAM, and I had 3 different brands. I had 4 lifts, and there were 3 different brands of lifts. And they all had a little bit different gear ratio on the winch. So there's challenges there. Other issues I have them. There isn't a lock-off system. With a ground support system, the self-climbing system rather. There's a number of ways to secure the grid to the tower so that you're not relying on just the chain hoist holding the load. With a stick-built structure, well, it's stick-built. The legs are bolted in. With crank towers, you don't have a positive lock-off in them. There's nowhere to shove a pin through the thing to make sure the mass is going to stay in place. You're relying just on the brake in the lifting mechanism, which takes us to the last point, which is, a lot of these things are materials lifts. They're designed to pick things up and put them in place. They're not designed to hold them there. Now, in the last few years, there's been more focus on entertainment, and some of the lift manufacturers are producing their products designed to hold load at trim height. I think Sumter is one of them. There's a couple of the European brand lifts. There's some nice equipment out there. They're getting there, but you still don't have that means of securing the tower once you walk away from it. That troubles me. I'm not a fan of self climbers, or not. Sorry, I'm a huge fan of self climbers. Not a fan of crank towers.
Elmer, before we wander off this slide, Mike asked. Well, you addressed one of his questions when you told what brands are allowed to hold loads at height. And the other one, the question, I don't know if you're going to address this later on, but don't people use span sets to hold truss against the forks when moving up or down? I didn't know if you were going to swing back to that later on or not.
You know what? Let's get to it here. As far as what brands, I know Sumter makes them. Genie has their entertainment line. There's not a unit, but what you get into is within a manufacturer, certain units are only designed for certain roles. So you really have to make sure you're looking at the documentation with them. And even some of the ones that are coming from companies you think of as entertainment companies, when you dig into the documentation, what you see is the model ABC is no problem, designed to hold. They have all the pictures of it holding a small line array at trim. Okay, cool. But lift XYZ from the same company isn't designed for that holding purpose. You can, it's even though it's in the entertainment catalog, you can lift with it, but you're not supposed to hold loads with it. As far as don't people secure things to the forks? Some do, some don't. You know, it's, you know, does does every arena rigging crew in the country install shackles all the same way, or is there that one guy that sometimes that goes pin to pin or tries to put two things on the pin? I mean, you know, there's no, yeah, ratchet. Michael says that ratchet straps again can be useful. You have to look at how the lift is built. Can you get it around the back of the forks without causing it to bind? Some of the companies are building in, you know, connection points. They're making fork adapters and things like that, so you can, you know, clamp your truss down directly to it. And there's, I think Light Source out of North Carolina makes some you know, crank up fork adapters that are, you know, like bolt down. You can set screw them onto the fork, and there's a coupler to hold a tube or a truss. So there are people doing it, but that doesn't mean everyone's doing it that way. To engage whether or not they're appropriate for one or the other. I'm reading Brian's question. Is there an obvious design? You mean, Brian, if you mean for crank towers, no. You know, if you look at what's in E1.21 about outdoor structures, you know, there's language in there saying that once a system is raised, I think it's in there, the system is raised, you know, you're not supposed to rely on you're supposed to have a secondary safety on it. When you look at what the chain hoist manufacturers say, you know, except for when you get into higher design factor hoisting, if you're talking like a simple single brake hoist, you know, you're supposed to put secondaries in or have additional capacity when you're holding at height. There's no uniform answer on that.
Okay, I'm sorry. I was just curious because you know how it is. We always end up using those stupid hand crank towers.
Mm-hmm.
We all hate them.
Yeah.
But it's like, is there something really obvious that we're just like, yes, this is definitely suitable for holding at height, and this one is not? I mean, is there like a design characteristic, or
you have, well, so interestingly, there is a task group right now in the rigging working group that's working on a standard based around the use of crank towers. So give us a year or so and we'll have something for you.
If I may, Elmer,
Yeah.
just to answer that question, you really do need to check with the manufacturer. You got to go back to the specs and see what that particular model is designed and capable of doing. Do you want to continue with the questions, or do you want to?
I'll answer this one more Norm's question. Well, it's the intended purpose for these is to lift something up to a height so that it can be installed. And like I said, some manufacturers do build them with the intention that they have designed them to hold a load at trim height. But it's not a uniform thing. Even if you look in Genie's line, the SLs are super lifts, STs are super towers. The STs are supposed to be entertainment units. The SLs are the material handling units, you know, for literally for picking up HVAC ducting and things like that. So we'll talk more about it. Oh, go ahead, Bill. Yeah.
No, I was going to say, I mean, I'm surprised by the number of people who are asking questions about crank towers, because maybe I'm projecting here, but I was hoping that crank towers were not nearly as popular as they used to be in the bad old days.
Interestingly, I think they have seen a growth in popularity in the last probably 5 or 6 years, with all the companies bringing them in from Europe now. I mean, you know, Milo Serie 4 has their EXE line, which is I think out of Italy. Truss has some, and there's a ton of companies now. They've become a big thing. They've actually become bigger in Europe, is where it started. But in general, I think it comes down to I think one is a cost thing. And I think the other is a perception that they're less complicated than chain hoists or self climbers. I don't agree with that. I think it's a perception thing. But I think there's a idea there that they're ease of use. You just roll it in, you flip the legs down, and away you go.
Right.
It's simpler. It must be safer. Oh, if only. Gee, I thought I was gonna have something else be the hot button. Crank towers are the thing.
You never know where the
yeah.
landmines are.
I can take that blindfold off. All right.
We can come back to it.
Oh yeah. So let's talk about, and this applies to all the products, but the loads and the forces. What are we dealing with on these? It's it's pretty straightforward. We think of a tower, we think, oh, it's the force coming down on it. Is my pointer working? You guys see that, or
that mouse is working? Yeah.
Okay, good. So the idea is, we have something sitting up here, and the mass of that object is acting through the tower, and it comes to the ground. Cool. That's easy. That's what they all do. The reality is that, except for this totem idea, that's hardly ever how we apply the load directly to the tower. We always have some force coming down through the column, but you have to look at where the force really is. Now, in this case, here's a diagram of a self-climbing. Because the chain is going up and over the head block, we have the calculated force at the sleeve effectively bearing down. But because of the way the connection is made, it's not on the very center of the tower. It ends up being out to the side somewhere. So now we have eccentric loading. And as we know, Truss likes to deflect. So as we're putting force here, we're also going to push down on the sleeve. We're going to start putting a bending force into the tower. So while, yes, we have a force coming down, because the tower is trying to effectively, bend and kick itself out, the force isn't directly at the center of it. And this is why engineers hate sleeve blocks. A corner block does a little bit better job, in that normally the corner block, you don't have anything sticking out past the profile of the tower, hopefully. But you're still, as soon as you go to a goalpost structure or anything larger, we start putting this eccentric loading into the tower. We start putting bending forces into it. Now, compression versus buckling, because we have axial force, we're trying to make sure that the way that as the tower takes load, we're not going to start bowing the cords out and have the thing try and collapse under itself. So we have to resist this buckling force on it. But because nothing is simple, everything's it's happening at one time, we're having to counter all these other forces. Because we get a bending force in, it creates a better environment to try and have the tower buckle. So the actual maximum force on top of the tower probably isn't what's going to control the capacity. It's going to be the bending. If you think about it, if you can perfectly center the load on it, you don't actually need any diags in a tower. You can have a Varendeel tower with no diagonal members, just horizontal members between the cords, and it will handle the load just fine, because their main job is to keep the cords from pushing away from one another. But since we never actually get to put all the load perfectly centered on the thing, and it's never 100% perfectly plumb, we have to deal with twisting force and these bending forces. So we end up having lacing in them. Now, I'll throw this one out there, and you guys can answer over in the chat. In order for a tower to be a tower, what's the minimum number faces of diags it's going to have in the entertainment industry? Just type into there for a little bit. I see a 3.
You asked.
Yep, and I did not make it clear enough. Tough room.
But I'm going to go with 3.
I see 5. Which there actually is a tower that kind of, you could say that about. Anybody else want to chime in? So 2, 3, 5. It's 2. For the historians in our group, if you look at the old Tomcat 3-ring binder catalog circa 2000, they had 2 models of 12-inch tower product, Mark 1 and Mark 2. Mark II is what most people think of. 3/16 thickness cords, diags on 3 faces. The Mark I was diags on 2 faces and 1/8 inch cords. There was one slight difference in it that I can't remember today that made it technically not light duty truss, but for all intents and purposes, it was light duty truss that they rated, and we'll get into loading on them, but they said it was a 1-ton capacity tower. And then the 3/16 wall, 3-face diags was a 2-ton tower. They never specified how or where those numbers really came from. What about internal diags? Internal diags they help with twist a bit in towers, but their main job is when we're building the stuff is to help keep it square.
I'm sorry, it's to help what?
Keep the truss square while you're building it.
Okay, thank
Keep it
you.
from twisting. In general, you don't need internal diags in most common usage box truss. And in fact, I omit internal diags on projects all the time when they want to run cable trough or something down through the truss. Again, the engineers check off it, and unless we're really up against the capacity of the product, they're not worried about it. Is this not manufacturer specific? The number of diags or internal diags? I mean, it is manufacturer specific, but the internal, it helps with torsion, but I'll tell a little dirty secret here. There isn't any, if you look at the manufacturers, they don't really have a super hard and fast must be located plus or minus this 32nd of an inch. We get them in there at about the 1/3 point. There's only 2 of them on a 10-foot stick of tower. There's not a lot of them in there to really help as far as twisting. We're much better served in that respect with the torsional loading because we have the faces of diags. And again, as you get into bigger towers and we're seeing higher loads, we go to diags on 4 sides. And then you start going into even big, then you start going into, instead of 1-inch diags, you're using 1.5 inch. When we build 20.5 inch tower, those are always diags on 4 faces because the expected loads of that are high enough that we're going to need that kind of capacity. Unless it's a special order. Actually, I know of a stick-built ground support training structure out in California. All the tower is built with only 3 faces of diags. The 4th face is 2-inch members spaced out as ladders to climb the structure.
Yeah,
But it's tower.
Can you swing back to the original question of how many diag faces you get? And you said you only needed 2.
Yeah.
How big of a range? I mean, when I only need 2, is that on like just 12-inch?
Oh, I'm sorry. No, when I say 2 faces, I'm not talking about the number of diags in a face. We're about how many of the 4 sides of the truss or tower, how many of them have to have diagonals placed on them? I
understand that, but what I'm wondering is how big of a range? At what point do you move from 2 faces to 3 or 3 faces to 4? Because we're going to be out in the field setting up a rig that somebody else either rented it and brought it in. It's not our gear. We want to be able to look at it and go, oh, that's okay, or maybe that's not so okay.
So I fault my well, if you're setting it up for somebody, they should be handing you drawings that have been reviewed by an engineer. Ground supports.
Is it pretty where you live, Elmer?
I didn't say it's always what happened, but I'm saying it's how it's supposed to be. At some point, in general, even if you're talking about someone buying, we'll go to my old employer. Someone bought a Total Structures roof system in 1994, and they're still using it. If they're the original owner, they have the original engineering report that specifies what parts go where. Even if they haven't reviewed it for the project they're doing like they're supposed to. This is where it's challenging. In general, things like lighting totems, small stick-built go posts, things like that, that 2-story trade show booth that I showed earlier, those are using regular light-duty truss for the legs. In general, 10-foot stuff handling a few 100 pounds, not seeing outside forces, things like that, inside stuff, light duty truss stored on end is acceptable. I get above 12 feet, 15 feet, I start talking about, thousands of pounds. Yeah, that's a different that's a different creature. That's going to be where we start going into, a product that has more characteristics built in to be a tower. At this point, nobody as a standard product that I'm aware of does a tower with just 2 faces of diags, mostly because they want to avoid confusion in their product lines. 2 faces of diags, it's going to be a truss. 3 faces is going to be a tower. Tomcat discontinued Mark I somewhere in the late 2000s, I think it was. Maybe even been earlier than that. I bet Keith would remember. In general, yeah, but in general with the ground support, if we're talking about a 10 foot or 20 foot goalpost, yeah, it's probably not engineered. But if we're talking about a roof system, we're talking about a big marking event with a structure that's been designed, there's going to be engineering for that, and there's going to be assembly drawings. God, I hope so.
So I'm going to toss out a phrase that I grew up with, in talking to truss people from, the way back.
Sure.
Tower can be truss, but truss cannot be tower.
That mentality, that approach has gone by the wayside.
Okay.
Us young punks, I think we know everything. Again, with proper review and design, yeah, you can use truss. You can use what's a truss vertically. I do it all the time. That Infinity ground support, that's all truss product. The legs are 10 to 15 feet tall. It's all 20.5-inch box truss. But we also spent a month with the engineers designing the thing to build 95% of it out of the customer's inventory. So, so you can make it work. In general, if we're talking about, a self-climbing roof system, stuff like that, yeah, the legs on that probably aren't going to be truss. Just because when you start getting into systems of that kind of capacity, you're dealing with a lot more force, and you want something that has, the biggest issue on towers is the capacity on the cords. The heavier material makes a huge difference, especially when engineers start looking at the force being applied to the cords by that sleeve block as it goes into load, and it starts to twist itself on the tower. So we've caved some cords in on some stuff in the past because we had too hard of a roller on it. That was
Hey, Elmer.
Yeah.
Uh-oh.
What's up?
We lost you.
Oh. Wow.
At least I lost you. I don't know. I can't speak for everybody else. But I lost you about the last couple of sentences. Well, they're saying you're all good, so never mind. It must have been me.
Weird.
Okay, let it go. Sorry, let it go.
Okay, that was strange. I've been having internet problems, so it wouldn't shock me.
Okay.
The other issue on towers is braced versus non-braced towers, and this is all these things are working together as we deal with ground supports, because how tall the tower is has a direct effect on its capacity, but also how we're supporting it. Is it, how much ballast is at the bottom? Can the bottom move? Is the top restrained? Do we have guy wires, or is it trying to be freestanding? If we're talking about really tall stuff, are we putting intermediate horizontals in between the towers themselves to keep them from trying to buckle? I mean, some of the really big roof systems out there now, even the aluminum grids, they're doing 75-foot towers out of fabricated 20.5-inch tower product, and they're putting some weight. They're putting 60,000, 70,000 pounds up there. So what we're having to do in a lot of these cases is, once the grid is up past the midpoint of the tower, is come in with additional truss and bolt it in between these towers to keep them from resisting. When we're building big wind walls outdoors, we're doing big video wall screens, video walls outside. A lot of the times what we're doing anymore is putting, it's not going to be a little 4-foot long arm. It's, the base is going to go out 15, 20 feet, and it's going to have a truss run going up into the middle of that tower to help brace it, to deal with all the forces that are going to be hitting it thanks to wind on that wall. So all these things, it's, this is all of these reasons and more why when people ask, well, what can a tower hold? I don't have an answer. It's the dreaded answer of, well, it depends. For those who are in the rigging working group, and we're working on the revision to E1.21, one of the public comments that came in from one of the other manufacturers that we really had to wrestle with, one of the requirements in the standard is that as a product that complies with the standard, you must provide loading information. And that was there for truss and tower. And the challenge with that was having, for horizontal truss load tables, it's pretty easy to figure out how to compare those. There's so many variables in how a tower can be constructed and can be used that without the standard really getting specific into exactly what criteria the loading will be created under. You losing me again, Bill? Trying to make sure.
I did just a little bit, but it was momentary.
Okay. With trying to create a standard product information sheet on tower, there's so many different variables in what would create that table that unless every manufacturer was doing the same thing, there's no way to compare that information. And because there's so many ways to use a tower, whatever it is the manufacturer gives you, 9 times out of 10 isn't going to be the information you actually needed. Because, why would you ever get what you need? Brian cites the problem I think we've all had on job sites in the comments. That's my computer. So, questions on, before I move on to the next one, any more questions? Any questions we need to get into at this point before we go any farther? Okay. So what'll it hold? As I said, there's a ton of variables with ground support systems and with the columns to give flat answers. The conditions for outdoor usage are going to be almost entirely different from indoor usage, depending on the structure you're building. Whether or not you have the ability to put ballast and guy wires in the structure or not. And that isn't just an outdoors thing. That applies for indoors as well. We'll talk about that on one. What's under your towers? What's the bearing capacity of what you're building it on? And what do you need to make it stay in place? And then again, we go back to the strength and the nature of the connections. Is it the bolted corner block for a stick built? Is it a sleeve block for a self-climbing system? Is it a structure strapped onto the forks of your genie towers? All these things are what we have to figure out to determine what it can hold, which is why I think we see a lot more engineering review being done for these kind of structures as opposed to a qualified rigger doing the load calculations and the load distribution maps for a truss grid, a flown grid. At least I hope that's the case. So indoors versus out. What are the things we have to deal with? Well, outdoors, we're worried about wind loading, right? But what about indoors? The picture that's on the screen, the structure on the left was a marketing thing that was put into some theme parks a couple years ago. All ground supported. We couldn't have any external ballast blocks. We couldn't have any large ballast blocks. Couldn't have any guy wires. And it's a 3-panel structure. You can't quite see the middle panel. And they were all 3 panels were filled with hardboard graphics panels. So, we've got this giant sail sitting outdoors, and it's about 15 feet tall when we're all said and done with it. That base, each one of those steel plates is a 4-inch thick chunk of A36 plate steel. And I think they were 16 by 24. And the frame is all 3x3 steel with quarter wall. Each of those bases, when we had them built out, weighed a little over 4,000 pounds. And that's for one sail. If I was doing that indoors for a trade show, yeah, I probably could build that base out of, I probably don't have a base even that big. For a structure like that, I'd probably have some 3-foot square steel plates under it, and I'd call it art. I'd have an engineer review it. But, a smaller base is going to do the job indoors, because I'm not as concerned with wind loading. Picture on the right is a self-climbing video wall system that we build, where the entire support structure is behind the screen. If you look up here, this little A-frame arm is actually an uprigger arm that clamps to the cross truss, and we clamp a Schedule 40 pipe to it for the video wall to hang from. So the entire load of the video wall is in front of the structure. This cart is a ballast cart. So you have this big aluminum frame, this ballast cart rolls onto it. Each of those plates is 150 pounds of steel. Plus the cart itself is 150 pounds. We like steel. That's what it takes for indoors. That was about a 20-foot wide wall, and we've got 750 pounds of ballast at each side. Obviously, in a structure like that, we're worried about overturn because of the video wall, because it's all in the front of the structure. But we're also, even if we had structure out in front to act as a counter arm, I'm still worried about wind loading on that structure. The air handlers in a good ballroom or a convention center can generate 3 to 4 pounds per square foot of pressure on that screen. And if you have it hanging like this is, or if you build it, in a goalpost where it's hanging in between two legs, it will start to move. And you get a big enough wall, and it'll start to move a lot. Or if you're in a convention center, and I saw this at Infocom a few years ago, they opened the show was over. They opened the loading bay doors at the back. There was a typical Orlando summer afternoon thunderstorm. Wind came through the bay doors, and took a big sign down from over top of somebody's booth, and dropped it in the middle of their booth. And everybody's video walls started doing this. And we quickly got them to close the doors back down before things got out of hand. Yes, sir.
Hey, Elmer, on the photo on the right, your cart. Did I hear you say that there are 2 carts? We just can't see the other one?
This is actually, there's a little bump out here in the hotel. The other base is over on this side where this tower is. So this cart is here,
Okay.
and there's another tower base just like this, 15 feet down.
Okay.
To Michael's answer, yes, we do regularly. When we're doing big indoor projects, when the engineers are looking at them, they've become pretty standard about applying 5 PSF to video walls and to scrims and to drapes for indoor stuff when they're analyzing what the structure has to look like. There was a project, it was a proposed project in Las Vegas a decade or more ago at the Luxor that they wanted to have this big, it was a Titanic exhibit thing. They wanted to walk into this big painted scrim that looked like the shipyards. That'd be great. And they wanted it like 40 feet tall when you walked in, with 70 feet wide, but we had 5 or 6 feet of space to build the entire support structure. And it couldn't be done. There just wasn't enough real estate to get enough ballast in that footprint to counteract the force we were going to have to deal with from the air handlers.
Can we go back up to Joel's question about four up from the bottom?
Joel, is there a formula?
Yeah. I don't mean to put you on the spot, but I thought I'd put you on the spot.
There's let's say a formula. I mean, it's a calculation. Once you know what the load is going to be on the tower, so it's the decision tree. So you look at your horizontal span. Say you're building a goalpost. So we look what the horizontal span is. It's a 1,000-pound video wall. So we know we're going to shift. If it's perfectly centered, everything's perfect in the world. 500 pounds left and right, plus the self weight of the truss. Let's say it's 20 feet of truss, and the truss is 60 pounds a section. So we have 560 pounds of load going over, plus the self weight of the tower, 15 feet tall. So let's say we get up to 700 pounds. Well, now we know we have a 700-pound load coming down. Well, what's it sitting on? If we've got, this is fast and dirty math. If you have a 3x3 steel base, call it the calculator, because I don't do math that well. 50 divided by 9, you're talking about 85 or so pounds per square foot of load. That's with a lot of assumptions. What does your base plate look like? Is it really distributing the load that evenly, or is it a thin steel plate with stiffeners in it, in which case it's going to not be 100% even? Honestly, this is why I pay engineers. There isn't a simple formula to do it, because there's so many different variables depending on what you're building. You look at this base here for this structure. Yeah, there's, I say 750 pounds of ballast back here, but there's 2 screw feet that come through here, that actually come through the cart, 2 screw feet here, 2 screw feet here, and a screw foot out at each end of these arms. Obviously, all those, leveling feet aren't seeing the same load. And I am not nearly qualified enough to do math professionally to figure that out. I do know some riggers who are qualified to do that. But in general, those kind of things end up going to the engineers. In the case of this structure, we have a standard engineering report that specifies what the maximum load will be on the floor at each of those rows of connectors based on the amount of ballast and the amount of the weight that the tower's seeing.
Now, I'm going to do it again.
Do it.
Michael Saps's comment. I think, and we may want to wait until the end of the session to address this, but I think this is probably the frustration of a good portion of the people who are in this group today, because we are dealing with structures that don't come in with any kind of engineering. Short of the pick chart from the rental house that says you need how many 10s, how many 20s, and how many corner blocks. I think we're looking to figure out a way to do it right, and to better know what we're doing. And we're not always going to have engineers at our beck and call.
Yeah, and you're not necessarily going to have a manufacturer, because especially in rental situations, I mean, how many times does a pallet of truss come in and there's 5 different manufacturers on the pallet, and they don't all agree. It's hard, because it's really difficult to give a straight answer on that, again, because there's so many variables. Again, in general, someone's building. Oh, here you're stealing a little. I have toys. I'm going to stop sharing for 1 second. Okay. So look, I have Truss. Yeah, we have a 3D printer at the office. We have too much fun with it. So, that's your most common, truss goalpost structure. Sorry, I don't have corner blocks. In this case, these are actually modeled as tower. If you're building, a 10-foot goalpost, Stuart, we printed these. We made them at our office at Reliable. Something like this to hold, as an entryway or some lights or something. They're drawing to show probably truss for every piece of it. And it's really not something I'm going to be worried about. There was just a big old Facebook purse fight the other night over someone wanted a 4-poster built for a wedding and they didn't want base plates. Oh, that's, and have a bunch of people were like, oh, it's going to kill the world. If there's zero information available from an engineer, from a manufacturer, or whatever, then go the overkill route. You want to see, then you're going to want to see base plates because they're probably not going to hurt. The chances of them hurting are next to nothing. Yeah, I'd like to see tower product for the uprights if we're putting, building a 30-foot wide goalpost. Or I want to see, larger than 12-inch light duty truss if they're building a 30-foot wide video wall on 2 legs. It's yeah, I don't know that I have a great answer for you on this, guys. Yes.
I didn't mean to put you that much on the spot.
No. It is frustrating because, from the manufacturer's standpoint, we see these things as giant erector sets, and what's interesting is, as the manufacturer, I've encountered at times from some people that they don't really care what I say. They're the world experienced rigger and they know what they're doing and they've been doing it forever and it'll be just fine. Okay. Again, that Facebook purse fight, because somebody called out another manufacturer, I called the manufacturers in and said, hey guys, let's chime in. And there's 2 truss manufacturers saying, with what they're doing with this structure as described, you don't need to have base plates under it. And another 50 people piled on and said, yes, you do. The building's going to fall down. The truss is going to kill somebody. The bride's going to be paralyzed for life. I mean, it was ridiculous. There was 220 comments on this thing. Yeah, when in doubt, overbuild it. We're good at that. But on the other hand, you also need to be pushing the clients more to be planning. And I see it all the time at trade shows. I mean, how many, you rent a truss package from GES or Freeman or whoever. GES is notorious as, and you don't know what truss you're getting. A pile of stuff shows up in the aisle, then a couple of guys show up, and at some point in the next either 1 hour or 3 days, there's this truss thing over your booth with 0 drawings and no information. In general, it's, with smaller structures, 10 by 10, 15 by 15, 10 feet tall, it's pretty hard to load to the point where it's going to come down and kill somebody. Not impossible. But, using what I hope is industry common sense of, if the truss is missing half its material, don't use it. Make sure there's bolts everywhere. Then you might be okay. Now I say that, and I can open up my regular truss school deck, and I have an entire section about how badly connections get put together at shows, and stuff that I've witnessed that somebody thought was perfectly fine.
The best place to see stuff being done incorrectly is an entertainment industry trade show.
I've had some pretty good pictures come from trade shows.
Sure.
And then I usually go find a bar and drink for a while to make the shakes go away.
Elmer, we have 30 minutes left in the official session time.
All right, let me move it along a little bit. I'm a little long-winded here. Come on, stop that. There we go. So we talked about ballast and guy cables. Sometimes you don't need guy cables. Sometimes you need more of them. On the left is a permanent installation I just worked on. That last winter? No, when was that? Yeah, it was last fall we did that. Church going to outdoor services, and they needed to support video screens outside. Really nice building. They really didn't want to have cables running everywhere. Plus, you can see all the sidewalks. So we designed the system that everything this was 12 feet tall. Let's see, 13. That's a 13-foot tall structure to the bottom. And it was about 16 feet wide. And we just had them pour a strip footing. There's basically 5 feet wide, About a 5-foot cube of concrete under each tower. Great, no problem.
Did you bolt to the concrete?
We actually embedded anchors, 16. We embedded threaded rods 16 inches into it.
Right. Okay.
So because, and I've done some with like Hilti epoxy. For a 4 tower, it works a little bit better for goalposts. You really need something that's not going to work its way out of the concrete. So we end up with, tying into the rebar and embedding, 12 to 24 inches in some cases. Now, I will admit there are some little cables showing in the picture. They're actually to keep the line array, the little baby line arrays from swinging in the wind to mess with the sound. But the structure itself, lives outdoors permanently now. No issue, no guy wires, it's fine. On the right was one of my old clients' outdoor stage roofs for a Zach Brown show, I think. And they got a heads up from their weather monitoring people that a bad storm was coming. So they, got everything down off the grid. All the lighting rigs strapped to the deck. All the drapes are pulled. And in addition to already having all this base detail and guy wires in place, they had a bunch of extra racks of scaff, and they just dropped those all around the structure and threw about 10 more guy wires on. Because the weather guys were like, well, you might get hit with 40, you might get hit with 80. What's it going to be? We don't know. Good luck. So some days you add extra. It depends on the project. For temporary stuff, guy wires are much more common because you don't have the option of putting foundations in. Yeah, my car, as long as you do something to make sure no one can move it. We've all seen the pictures. We've all seen the pictures of stuff safetied off to the truck, right? And then there's urban legends out there of, somebody didn't know that their box truck was the ballast for stage right and drove off. For temporary structures, like I said, ballast blocks, earth anchors sometimes, but guy wires are much more common. Permanent installations, if we have the means to dig holes and dump rocks into it, great, let's do it. It makes it cleaner and things. Then there's the hybrids, that Infinity project, because it was for the Pebble Beach concourse, which is, let's just say, for a more refined audience. They actually came in, graded the site for us, poured concrete foundations, set earth anchors, all that, because they couldn't have any wires anywhere. I was like, oh, if your budget does it. David, we will get to your question. I'm calling the rest of you my peers, a finer group never assembled before. Right, yeah. Sometimes you need ballast and guy wires inside. Anybody know that one? That was was it RH Ramen? Yeah, Scott, that's the ramen show up at what was the Pontiac Silverdome in Michigan.
Silverdome, yeah.
Yep. Great, a well-designed structure that was not reviewed by someone that was qualified, and the system was not installed correctly. That particular type, well, what the Thomas roof that had been, is required to have guy wires coming off of the sleeves from the towers, regardless if it's indoors or out. It's how it's designed to work. And they didn't, for whatever reason, those guy wires and ballast blocks didn't get installed. Sometimes you got to have them indoors. And that's the thing is it isn't this thing where, oh, if it's inside, it doesn't need ballast. If it's outside, it does. It depends on what you're doing. I just designed some stuff for that's being used at some NASCAR events, and they had a little meet and greet press stage, and it's a 8-foot deep and 20-foot wide, 20-foot tall truss box. But because of what they're doing, we needed 600 pounds of ballast for it total for outdoors, because of the way they're building it and the way it's covered. That's all the engineers called for was 600 pounds. So we stuck a base plate at each corner because it was the easiest way to put 150 pounds on each corner. We welded up some big heavy steel bases for them. But that's it. Whereas, indoors, again, that video wall, well, the pile on the floor there is a pretty good example of sometimes you need it. Yeah, Anthony, same kind of idea. It's, there's no hard and fast rule of you have to have a guy wire for this condition. You don't have to have them over here. Michael brings up an old project. And it's funny, I just came across those pictures recently. What he's talking about, this was an outdoor permanent art installation. These were like 30-foot tall towers that were being installed along a state highway in Iowa. So wind, the towers were wrapped in perforated sheet aluminum. And then on top of the 30 feet, they had this kind of looked like an antenna array lighting assembly for another 10 feet tall. Permanently outdoors, had to survive. So we didn't get any wind reductions. They had to survive. I think those were rated to 90 mile an hour, 3-second gusts. We ended up building a custom triangle shaped tower. I think the main cords were 4-inch diameter, 3/8 inch wall. Diags were 2 by 3/16 and bigger in it. Some of the box section, there was some 3 by 3 box section and stuff. It's, again, when you can design to it, you can do, that was one that we couldn't have guy wires. There was, I think, 3 or 4 yards of concrete in every foundation on a tower that was 36 inches in diameter. So, it varies.
Hey, Elmer, can we go back up? And
Yeah.
Brother Michael asked a question that I have always wondered. Guy wires on sleeve blocks or on tower tops? Is there a preference? Is there a no-no?
In the dream world, you have both.
Okay. Well,
In most cases, there's some guys that swear by guying the towers, and that's fine. If you do that, though, if you do guide the towers, then you also have to make sure that you have cabling in place between the towers so that if the grid is brought down, the towers don't start splaying out. And what you're not getting by attaching the towers to the sleeve is you don't have anything giving you uplift resistance on the grid. So if you do that, you still have to include cables that are going to go from the sleeves down to keep the thing from lifting. And you can start doing some weird things on towers. In most of the engineers working in the industry, they want a guide to the sleeve. They want control of that. Because the other reason is, if you have to bring the rig in at some point, it's easy. It's a little bit, you're only having to adjust one set of cables instead of 2 sets if you're guided off to the towers. Because again, if you guide to the towers, you have to make sure that you're not splaying them out once you start moving the grid down. So it does get complicated. Plus, if you're guiding to the towers, you have to tie it in between. Otherwise, you don't have anything giving you resistance when you move out once the grid's out of the way. I kind of repeated myself there. So yeah, in general, sleeves, easier, better, more control.
okay. Thank you.
Sure. Bases. Someone asked about water totes. I love water totes until they leak. In general, I don't care what you're using for ballast. A ton of feathers is as good as, a ton of concrete if you have the space. It depends on the design of the structure as to what you need. Now, we're back to the booth I had. I've built a few times. It's a 20 by 20 trade show booth. It's a 2-story structure, and I've been questioned by the Las Vegas Convention and Visitors Bureau engineers a few times about why there's no base plates. They don't do anything. On this structure, I've got knee struts. I have knee bracing up here, taking the leg up to the grid in 2 directions. I've got in this structure, there's actually 6 legs. There's a small landing back here with a staircase coming off of it because it's a 2-story. I'm not going to get anything. I'm not going to get any more stability on this structure putting a 2-foot or 3-foot or 4-foot base under it than without. It's not going to go anywhere. I'm indoors. I'm not worried about wind loading. I'm not worried about overturn. If I was doing it outdoors, yeah, there'd be bases and there'd be ballast blocks. A little, baby G or mini G block in the bottom of each leg wouldn't be unusual for something like that. But for indoors, there's no reason for a base. For this system, this is an outdoor stage roof. Those are 20-inch towers. They've got I-beams tying them together in multiple directions, and each of those totes is 4 feet by 4 feet by 2.5 feet filled with water. And they've got a pair of those in between basically in between every set of towers. Water totes are awesome. Love them. They're great. But you have to, keep in mind what you're working with and how big the base needs to be to do something. We'll go back to Michigan. They had bases on these. Now, for a number of reasons, they didn't do anything. But even if they had 5,000 pounds of ballast sitting on the base of these without the offstage guy wires and ballast blocks, they weren't going to do anything. And this is where we get into this question of what do we need tower, you need bases and outriggers on these big, multi-leg structures. Think about what you're dealing with now on a single. Here we go. On a single column. Let's stop sharing for a second. We'll go back to drawing again. So I just like playing with my toys. So here, single tower standing up here. There's not a big footprint. It's easy for this thing to move around. So we do need to do something to keep it stable. Same thing goes, for our goalposts. And a lot of times when we're building goalposts, especially for outdoors, we'll add, let's see, I'll turn this one this way. These really are the most fun things to have for teaching classes. A lot of times you'll see, and this is why I'm wearing white, as you can see this against my shirt. When we're building a goalpost for a video wall, indoors or out, we'll have truss running front to back to make that footprint much, much larger. Because that's what's going to keep it stable. Makes sense, right? At this point now, in order for this thing to fall over, we have to resist, this much more length. Now we're, side to side stability is an issue, and we'll often run truss to the sides as well to help with that, or we'll tie it together in between to make it a rigid frame so that it doesn't try and make a parallelogram out of itself. When you get up to 4 towers, though, and if I'm boring you with playing with my toys, I'm very sorry. When we start talking about a 4-tower structure, and for some reason I only have 3 of these. Let's say we have all these locked together, and we've done some. If we're outdoors, we've got ballast down here anyway. We don't necessarily, if we have a base plate there to hold the ballast, we may have a ballast block parked next to each tower and strapped off to it. But if we have this here and it's guyed out, we're not really worried about overturn. The guy wires are going to handle uplift. We're not worried about it picking itself up and coming down crooked. And we're not, and the guy wires are going to help us deal with lateral stability. Plus, we have the thing, all 4 legs locked together with this upper grid. So we have a locked spacing at the top of the towers, and there really isn't anything to act on the bottom of the towers. What difference is a big base and outrigger arms going to do? Now this is, say 10 feet. Let's take this up to a 50-foot tall tower. What is a arm, a piece of 2x4 aluminum sticking out 4 feet going to do to make that 40-foot tall tower any more stable? When we've got thousands and thousands of pounds up at the top of it acting on this gigantic lever. Questions about that? Because that one I usually get argument on that one.
Well, you're not going to get an argument from me, but I'm going to bring up or ask you to talk briefly about ballast. And I know Paul Taylor put in the chat, he put, which I'm still in the process of downloading, even though I have it somewhere, the Thornton Tomasetti Indiana State Fair thing, their report. But I think a discussion needs to be had about, you got ballast and you got plenty of weight, but then when you put it on wet grass, where you at?
Sure. Well, no, I mean, it's, it's the idea of, well, my car is safer because it has seatbelts. No, you're safer because you use the seatbelt in your car. Just having the thing sitting, and this is where we get into the argument with the outriggers and stuff. People, well, that base and outrigger is going to be safer. Not if you're not using it right. If when you're dealing with ballast, you have to make sure it's going to stay in place. If it's not going to stay there, then it's not really ballast. So yeah, if you're on wet grass, then that's about one of the only times when I think circus tent stakes are okay. I don't believe in using tent stakes for attaching guy wires to, but I have no problem pounding a bunch of them in front of a ballast block to keep them from sliding. Seems like a great idea to me. If you're on concrete, then you need something to increase friction. There's some thin rubber mats that do an amazing job. You got to have something there. You're on gravel, well then either get rid of the gravel and get down to dirt and drive stakes in, or drive some stakes into it. If there's no way to keep the ballast in place, well then either you add more and more and more ballast till you can, or okay, let's look at earth anchors. Let's talk manta rays or duckbills if it's a smaller system. But yeah, if your ballast isn't going to stay where you stuck it, then okay, we got a problem now.
And I think it's important to note that it doesn't take much.
In a lot of cases, it doesn't. And it's it's same thing in rigging. The ideal on guy wires is we want them 45 degrees out from where our attachment in the structure. We want a nice 45. That's where life is great. That's not to say we can't have it closer, but the closer we get to the structure, the more ballast we need to do the same job. And when it gets all the way down to, if you can only have ballast around the base of the tower, then you need to have a big framework sitting there to whatever the maximum space you can have, so you can pile that stuff on there. It's not uncommon to see something where it's like, well, in the ideal world, 45 degrees out, we need a 5,000 pound ballast block. But when we get down to, we have to be at a 15-degree angle. Okay, the engineer might say I want 13 or 14,000 pounds of ballast, 20,000 pounds of ballast, which isn't always realistic. So then we go, well, what's our other option? And that's when we start looking at earth anchors, which are fantastic.
You start looking at
earth anchors.
Okay.
Something, not tent stakes, but engineered earth anchors. Manta ray is a big brand. Duckbill is another brand of them. There's a bunch of them out there, but these are mechanical devices. They remind you of a small boat anchor, where the piece is like a sand anchor, where the piece flips out, you drag it in the bottom to hold your boat in place. What these things are is it kind of looks like a spade shovel with this pivot. You drive it in, usually with a power hammer, like a braking hammer. And then once it's in, you have to then come back in with a chain fall or a come along and pull it back out to get that blade to pop open and set into the soil. And these things are sized by the manufacturer to give you X value of pull-out strength for ABC soil condition. Everything from loose sand to hard clay. And they have all different size anchors. So it's like, I need 5,000 pounds of capacity. And I'm working in, Iowa or Kansas, rich, dark soil out in a field. Okay, you need model BZGR manta ray. And you're gonna drive it 4 feet into the ground. And it has a piece of galvanized aircraft cable attached to it with a thimbled eye. You pull it, you put a dyno on it to pull test it, and voila, you got an earth anchor. And then when you're done, dig around it, cut the wire off about a foot in the ground, and pretend you were never there. I mean,
so why aren't they more common? Cost?
They're not cheap, and they're a throwaway.
Right.
The small duckbills are $40, $50 a piece. Some of the big manta rays are $300 and $400.
Right.
I can go to my local concrete guys around here and buy K-rail for about $200 a section.
True.
So, But again, we go into the conditions. If it's a situation where you can't get a forklift into it, or it's someplace really, really pristine, yeah, Scott, if you're gonna do that, you're gonna maybe do something else too. Sometimes earth anchors are the only way to go. Stanford University, I I know they rebuilt their stadium recently, so I don't know what they're doing for commencement, but they used to have a stage roof system for commencement. And every spring when it was setup time, the groundskeepers went out, they had a metal detector, and they swept around and they cut the turf, peeled it back, pulled a plastic bag out of the ground that had the end of their earth anchor that had been greased up. And they went over to the same thing where the tower footings were, cut it out, moved the dirt, and there's a concrete pillar sitting there with the studs ready to grab the towers. Nobody knew it was there the rest of the year. And it was magic. It was great. But they had the ability to do that because it was there in the same place every year. And like I said, sometimes you just can't stack enough ballast. A project supposed to be on one of the piers out in San Francisco a number of years ago. And for everything they were doing, the engineers ran it and said, all right, no problem. Need 1.2 million pounds of ballast. That was the answer.
Right.
And they were like, wait, what? Yeah, 1.2 million pounds, no problem. Because they were told they couldn't, do any anchors. Suddenly, they found a way to actually drill through the pier and bolt everything down.
Right.
It's amazing.
Right. I think that's an important part. Important point. We were called in at the last minute to hang banners off the UN building in New York City. I forget what the event was, but it was some big international thing. Week of the whatever, and so we went in. We brought our engineers in there. There's no place to tie off to. Clearly, you're not going to drill a hole through the roof of the United Nations building, and so they came up with the ballast that was required. And it was astronomical, of course, and the roof would not have held the ballast that we needed, and they didn't do the job. And it's important, if you're involved in something like that, to understand that there is a point where you say, no, you just can't do it.
Yeah, it's not. You just reminded me of a job I did up in New York a number of years ago too. Events marketing company. Those guys come up with some crazy stuff. And it was for the Stamp Out the Hunger campaign for Snickers. And they were going to stick, I think it was David Arquette, in a glass box on top of the marquee of the Madison Square Garden. And it was one of those instances where, totally outlandish plan. They're going to stick this guy up there for like a week or something. And I think the building told them, hey, you know what? Here's the loading capacity of that roof. If you guys can figure out how to do it, by all means, knock your socks off. And then I got a phone call from the client going, can we do this? And we were limited to something ridiculous. I think they allowed us like 20 or 25 PSF to put it was like a 10 by 20 structure, glass box structure out of 12-inch truss. And it had to be anchored down. We did it to the point where I think the guys at MSG were annoyed that, they threw the challenge down and someone was like, all right, here we go. And it was the most outlandish thing. I'm like, okay, guys, the footprint's going to be like 30 by 40. And here's what we're going to do for connect, and the engineers were like, oh yeah, we can make this work if we do this and this and put all these spanners in and all these spreader pads. And I was like, if you want to do it, this is, and everybody bought off on it. And it was a fun gig, but it was just one of those, I was like, when they came to me, I was like, no, there's no way we can do this. Proven wrong. I have one more slide to talk about, and then I guess we can dig into questions.
Go ahead.
This is the last one we talk about connections. How do we get from the vertical to the horizontal? As I said at the beginning, stick-built structures, it's pretty straightforward. You've got a bolted connection. Great, no problem. This is at a college out in California. I did this not long ago. Which I'll bring up something about the base on this as well. But they needed a little lighting grid for one of their film studio areas. And the ceiling couldn't handle anything. So we did this, and for what they were doing, the added complications of a self climber just didn't make sense. It's not like they can bring it down in between, lighting sets and change the lights on the ground, because they're not going to tear the set out, in between every take. So, short and sweet, it's a corner block, it bolts in. But here's the fun thing about corner blocks. There really isn't any standard engineering for them. We acknowledge that we use them in truss spans, and they act as a frame, and except for a few loading conditions like center point loading, when you have a corner block at the center, they don't really negatively affect the span. But as far as knowing what the strength of a corner is at the junction, there really isn't a whole lot of preset pre-packaged data on those, and partly because there's so many different ways that a corner is made. The way you make a basic 90-degree two-way corner with open faces on the outsides and top and bottom, it's going to act differently than a six-way corner where every face has those big gusset plates welded to it, or these corners are 3/8 inch plate fully welded edge to edge all the way around. They all act very differently. They frustrate engineers a little bit, not as much as sleeve blocks, but a little bit. One thing with this structure, because of the way the studio is set up, it's not bolted to the ground at all, and we don't have base plates under it. They didn't want bases because they didn't want it to get in the way of camera dollies and things like that, with the base plate sticking out. And it's California, so there was question about earthquake problems. And in general, truss structures don't get designed around the seismic requirements. There's usually not enough weight in the structure itself where seismic is the control. Something else is going to control before we get to seismic. But in the case of this one, it actually helps us a little bit, because if there is, a moderately sized earthquake, the structure will walk itself across the floor, but it's not going to fall over. It'll run into a wall and stop. Whereas if it's bolted in, we run a risk of damaging connections because of that rigid connection throughout. Yeah, kind of a fun. I don't know how many people know him, Ian Coles, who used to be the president of Total Structures. When when I first started working for him, he told a story. I think it was when the Northridge earthquake hit, the mid 90s. Total at the time was Total Fabs, and it was in the back of LSD's shop. Well, they went home from work after that. At the end of the day, they had test built a roof system that was going to a client, and they built it inside the shop, left it up at trim. The next morning they were coming in, take it down, pack it to ship. Well, the earthquake hit while they weren't there. And it was a couple of days before they could get to the shop. And he was, Ian was a little worried because this thing's sold and supposed to be delivered. And he's afraid it's going to be a pile of scrap in the shop. He got to the building and the grid was in perfect shape. All the legs were perfectly plumb. It was all good. It was just 15 feet away from where he had built it. It had during the earthquake, it had walked itself across the floor of the building and stopped when it hit the outside wall and just sat there. So they pulled it back with the forklift, got the grid down, checked everything, and it was fine. Yeah. Now, the sleeve connection, the moving block, if you ever meet an engineer that tells you he loves working out sleeve block connections and how great and wonderful and simple they are, you may want to either have him drug tested or just question his sanity, because they're a nightmare. Because of, you literally have all these different moving parts going on. You have the bolted connection to the grid. That's great. So it's acting as a corner and trying to keep these trusses together. But it's not physically attached to the tower, but it acts on it. And the engineers have to look at, in the case of the way we build these, yeah, that too, David. Yeah, this type of sleeve has 4 rollers at every chord. Some manufacturers have them just out on the point. Isn't necessarily one's better than the other, but the engineers have to look at what force is being applied into the cords and all the different loading cases for all these rollers to make sure that they're not over, creating an excessive point load on the cord when the thing's being loaded and used. We don't have a good positive connection for up or down, so it has to be locked off in a few different ways. You have to make sure you're resisting uplift on the grid. You have to make sure that you're also resisting gravity. You don't want to have it resting on the chain hoists. Ideally, it's when you're not using it, it's supposed to be locked off. So you have to figure out, a way to do that, and how there's just a ton of moving parts, and depending on the size of the system, there's a lot of them. In the case of this roof, there were 10 in the system, and all of them had to be looked at for all these different things. So they're really they're great. They're easy. They make, it's great to work at ground level, but man, they make the math hard. Which is why, again, we go back to this, as you're getting into these bigger and bigger and more complex ground support systems, they really want to be getting looked at by, a qualified design professional, not just, throw it on the truck and take it out and build it. And yes, I know the sky is amazing color in my world, and glasses and all that. Yeah, so that's kind of what I got. What questions do you all have?
Is there a detail on a corner block like the photo you've got up now? Is there a detail on a corner block that would indicate that it is got a better structural quality to it, I guess is the way I want to put it?
Well, yeah. So yes, there are some things to look for. So in a more like this is the newer plate style stuff. Let's use this as a better example. So this is kind of the more common appearance of a corner block as far as having bolt plates on it. Let's say this was a two-way corner block, though. We just had a connection for truss here and here. A better built corner is going to have a diagonal member closing off this face. These open faces where there aren't bolt plates, to help the frame keep its shape. And you want to see diags on the top and bottom faces as well. In general, what you're looking for is members in there to keep this thing from trying to rack itself. Like I said, if it's a six-way corner and it's plated the whole way around for connections, those are really good at keeping it square in all the faces. If you don't have those, then I want to see something else, to give that strength.
So you're looking at it from a layman's standpoint. You're looking at making sure that there are elements in there that are going to keep the corner block square.
Yes.
Okay.
Yes, that's the short and simple way of saying
it. Yeah.
The way I did it.
Yeah. A couple of questions in the chat you might want to look at.
Let's see, we'll start. What's the proper ratio of brace size to pedestal to base size to pedestal height? Depends. You forgot to tell somebody to keep count. You should have done that this time, Bill. So I'm terrible with that answer. It depends on what you're doing, right? There isn't a ratio. I mean, if you look at scaffolding, they say 3 to 1 is the ideal where you're starting to do more bracing. It's. Are we talking about indoors or outdoors? Inside in the ballroom, I think you're going to be okay with a 10-foot stick of truss on a 2-foot square base or a 3-foot square 30-inch square base if it's got a small moving light on top.
Yeah, but at the same time, if you don't, now I have to worry about what's the audience access or what's the client access.
Yep. Yeah,
what's the drunken access to
absolutely.
That? No, and that's going to change it also.
Right. Oh, most definitely. Yeah. I mean, I think the first New World Rigging symposium that you worked on, I remember there being a bunch of 12-inch uprights along the back wall. And there was a couple of sandbags thrown in them with a base plate and a few sandbags.
Right.
With our audience, not worried about it.
Right.
Not unless somebody's going to be having fun. But at Tammy and Jeff's wedding, I could see Uncle Carl having a few too many and leaning up against it, and the projector's not going to be 10 feet in the air anymore. Um, when we start talking about like an outdoor goalpost for a video wall for a temporary one, if we're talking about a 15-foot upright, I expect that I'm going to have 10 feet of truss running front and 10 feet of truss running back, and probably 5 feet off each side, with some ballast to keep it stable.
Right.
So there your ratio is what, 1.5 to 1. So there isn't an easy one there. Sorry.
What about David's question about, and David, I'm going to assume here that instead of corner block, you're talking about a sleeve block.
That was going to be my guess. Feel free to
That's
wait.
correct. Yeah, for when you're locking
Yep.
that sleeve block at height, so that you're not hanging it on the chain.
Yep.
What's your preferred method?
My preferred method is what I did here. If you look right there, there is a big double steel tube member, and you take this roof up to trim and you shove a 2-inch thick by 3-inch wide aluminum bar right through it and park it on it. I think that's great.
Where I didn't see that.
No, it's I'm being a smart ass. I'm sorry. Up in the tower, in these towers, we actually, and you can see it better right there. We
Okay.
actually built a lock off into the tower.
Cool.
But there's like 97 caveats. Thank you, Jonathan. There's like 97 caveats that go with that, because this roof system has a base detail where the bottom of every tower are all the exact same plane. They're all the same 0, 0. So then the top of every tower is the same, plus 45. And the grid always trims at that height. So you don't have flexibility with that approach. When you need flexibility, I'm a big fan of, of having a head block built with either building the head block or retrofitting it, so you've got the chain shivs for the lifting chain to go through, and then have a cable shiv next to it. And once you get up to whatever height you want, wire rope over the head block, coming down and making a physical connection off on each side of the sleeve. And the way I've done them, I'll use a stack chain, a stack on one side, and I'll put a turnbuckle at the other, so that I've got coarse and fine adjustment.
Okay.
1/2 inch wire rope, 3/4 inch shackles in most cases is enough, and some of you can do it with even less than that.
Okay.
I've seen Michael Gag, steel flex over the head block. I've seen 10,000 pound 3-inch ratchet straps done. There's a lot of different ways to do it, but definitely think about it, and before you get on site, please.
Yeah, I keep having the argument with one of our suppliers up here that it needs to be safetied off so that the weight's not on the chain, and I keep getting, oh no, it'll be fine.
Yeah, every time I think we're getting ahead on some things, then you hear those conversations. But no, it really, you need to have, there's a lot of ways to do it. Again, you can do, round slings, basketed off to the sleeve, to a flat strap set over top.
Yeah.
The big thing you have to watch for is you want to make sure, and I've seen it done going perpendicular to the head block. You just need to make sure that you're not deflecting the flanges on the head block, or
Right.
potentially cutting your straps. That'd be bad.
Right.
And if you go around the end of the truss, again, make sure you're not caving members in.
Yeah, especially not so much indoors, although I want a safety off indoors, but especially at outdoor festivals and stuff like that. That's been a continual headache for the last 10 years.
Yep. Yeah, absolutely. And Michael, to your question, you're right. We're not dealing with uplift. We're dealing with defying gravity. Again, the guy wires to the sleeve blocks going down to the ballast blocks or earth anchors are what's going to take care of our uplift issue. What else do we have in here? Self-climbing. Can the motor be attached at the base instead of the inside? Yes. Okay. So Joel's question, can the motor be attached at the base up and over instead of having it in the truss like the picture shows? And does it make a difference? Yes, you can. Yes, it does. By having the hoist in the truss, we're effectively double reeving it. So we now take our 1-ton lodestar in that picture and give it a 2-ton lifting capacity. If we anchor the hoist at the base, it's acting as a single reeve unit. You'll also see, which I don't like them, and certainly I see the trade shows, you'll see some ground support systems where they have a head block, but instead of being a head block, it's actually a rigging point, and they'll have a hoist hanging from the head block and doing a single pick down to the grid. So again, it's a single acting hoist, so you don't get the double reeving effect out of the hoist. So you potentially will end up needing to go to a larger hoist to do the job. I think it's pretty sure they wear the brown steel roofs. They have winches sitting at the bottom of the towers. So they're single acting, and I think they're like 10,000 pound capacity winches at every tower, because they're just too big to go up in the air. So yes. Proper ratio. What's your preferred method for locking a corner? Okay, we already talked about that. Summer. Okay. Anything else? Double check with the manufacturer. Yes.
Scott England, picture of a chain block in an earlier picture.
I'm not seeing that one.
Yeah,
Yeah,
that's down at the bottom,
Oh,
next to the last.
I swear he had he in one of his earlier pictures there was a chain block that was just being picking straight up there, right there.
it's holding the audio. Yeah, and it.
Oh yeah,
I did not provide that part of the job.
Yeah, but it's in your picture.
I know, and it's my example of what I don't want to see you people doing. Kent Brown Gallagher. Yeah, that one. And I think that's when they were doing testing, and I really hope they've changed it since then. But yeah, I gotta wipe that out of there. Yeah, things that make me.
I saw a chain block. I just couldn't remember the.
Yeah, no, there is one. It's, budget driven. We talked about that earlier. Any other questions? Anything else on anyone's mind?
I want to offer an editorial here. There have been a couple of comments today about where people are saying, yeah, but when they come in and they tell me, yeah, it's okay, and this is the way we always do it, and all those other lovely phrases that we all hate to hear. I want to remind everybody that I think it's probably safe to say every one of you have a device on you right now that will allow communication. And it's really easy. And I think, I know I speak for Elmer. You call up a truss manufacturer with a specific question and give them the specific, the details of the problem. You're going to get an answer.
Yep.
And you can get that answer in a very short period of time and go to whomever is saying, yeah, but this is the way we've always done it. And be able to either explain it to them why they can't do that, or have the manufacturer just hand the guy the phone and say, here, talk to the guy who built this truss.
I have been on those calls a number of times, and I tell people I get paid to talk. So
not today.
No, it's good karma for me today. It's I'm filling up the karma tank. It's good. It's getting paid. Yeah, absolutely. Call the manufacturer. That's why we're here. If something goes wrong, if when you end up with that picture of the Silver Dome and you're the company that manufactures the thing, even if you had nothing to do with that show, you're going to be involved. And I guarantee every real reputable truss manufacturing company out there would much rather take that call on a Sunday afternoon and head off the problem than Wednesday night getting the phone call of it just came down.
It's a habit that we're not in. The industry is not in yet because we haven't had that capability either physically or philosophically for so very long. It's still ingrained that in a sense, you kind of forget.
Yep.
But we need to remember that you can do that, and there's no stigma attached to that.
No,
or shouldn't be anyway.
No, it is. It's I don't know if some of it's just They don't want to be the guy making waves on site. I mean, I'll make waves. I don't mind. You know, I mean, you know, it's the same thing. If I'm working on a job site and I've, you know, here's my crew and this is the local crew that are the professionals. And I go, great guys, here's the job we're going to do. Here's the plans. Here's the thing. And if I get that guy on the crew that's like, well, that's not how we build it, that we're going to do it our way. No, you're not. The job's stopping right now, and we're gonna get this worked out.
All of this is very, you know, it's in our environment right now, it's very easy to talk about it, and it's more difficult to do when you're out there in the field toe to toe with somebody. But you got to do it. I mean, you know, people get hurt, people die, and
well, and it's, you know, someone pointed out, you know, it's your name on the paper. If something happens, anybody and everybody who's even remotely associated with it is going to be there.
Right.
I mean, just again, we talk about, you know, Indiana comes up. Look at the Tomaselli report. Look at everybody that was named in that thing. You know, everybody, you know, and we had discussion when we were working on the 1.21 revision. One of the people in the task group was actually a lawyer with the insurance companies. He's like, I've been in cases where, you know, we went to court and the judge said, no, there's not enough people here to figure out who's at fault. You don't have, he's like, no, there's more people than this were involved in this job. Everybody's going to show up and we're going to sort this out and kick the case back out until more people were named to the case. You're all going to be there. The job is to make sure you cover, you know, you're actually doing good work. You're documenting what you're doing, and you're you know, you're following all these practices. So.
okay. Anybody else?
I still want someone to do a really good seminar on guy wires.
Yeah.
I
Okay.
still think it's one of the most misunderstood and underestimated devices in our arsenal.
Yep.
And
Agreed.
underappreciated.
Agreed.
Way underappreciated.
I'll take that under advisement.
Thanks.
But I'm
Bill.
going to wrap up today's event. Elmer, thank you once again. This was good fun.
Oh, Bill,
Lots
thank you
of
for
good
inviting
stuff.
me. This is so it's a bit of an honor to be asked to come and play in Uncle Bill's backyard.
Let's not get carried away here. And all of you, thank you for joining us. How many people do we have? About 38. I just want to make a quick announcement that we have to finish off March. Next week, we have a session on mental health. Lori Rubenstein is going to talk to us about the behind the scenes program. And the following week is an open mic session. We're not going to have a topic in particular. We're going to talk about things, and I'll put out a bit of an agenda at some point, or at least some suggestions before then. But that's what I've got scheduled so far. There will be a couple of announcements coming up, and you know, we'll go from there. And no, Davin, there will not be singing. At least I won't be anyway. So thank you all, and stay safe, and have a good rest of your afternoon.
Thank you all. Appreciate you all coming out and joining us.
Elmer, I'm going to hang out for just a little bit.
Sure.
Most of the people go away because when I turn this thing off, it's just a guillotine, you know, boom,
Yep.
it just shuts down, and it's not terribly polite, but no, that was good.
Cool.
Do I let Daniel and Jeff know that you did product placement for them today, or?
Honestly, I'm like, I need something light colors for this Truss shows because I'm wearing a dark gray t-shirt. All my reliable stuff is black or dark gray.
Right.
Like, and they molded the Truss in dark gray. Great, yeah. So, you know, I gotta keep their name out there. And hey, they have a new employee they have to keep busy.